All right, here's a video for assignment number 2 on today's date, which is 7/7, day 6 of our summer school. And here's a work sample alert problem. So please, on your paper, please put the correct heading. This will be semester 2 for you. And today's date, Algebra 2, semester 2, your first and last name. You can print a copy of this worksheet or just do it on a sheet of paper. It doesn't matter. Either way, you're going to just take a picture of it and send it to me through the Google Classroom assignment. You're going to attach it to the Google Classroom assignment and send it in. All right, so let's look at 6.2a in this video. So I'm going to move to here. 6.2a. The Miro links are in your virtual classroom on the home page of your website. If you want to go to this link, you can, or otherwise just watch the video. Here's your exponent rules, and here's your logarithmic rules. We're just going to look at these exponent rules right now. And so if you look at number 1, it is just like the first one there, you're multiplying the same base. So that means you're going to add these two little exponents, and you're going to get e to the 7th power. Number 2, you're again having the same base, so you're going to add these two, and you're going to get e to the 5th power. Because when you add a -3 plus a +8, you actually subtract because they're different signs. You get a +5. There's more positives. The third one, you are dividing. And if you notice over here, this division rule means you're subtracting the exponents when you're dividing the same big number. So we are actually dividing the same big number here. We're dividing the same e. Now the 12 and the 36, you can just reduce on your own. 12 goes into 36 3 times. But you're going to take 5 minus 2. You're going to subtract these two. 5 minus 2. So you're going to end up with a 1 on top from the whole thing. You're going to have a 3 on the bottom. And then you're going to get an e to the 3rd power. Now you could put it on top or you could put it next to it. Either way, it doesn't matter. Either here or up here on top works. So your answer could technically be this, or you could have e to the 3rd power over 3. So both answers actually work there. So that's number 3. Let's look at 4. 4, you've got another fraction, 15 and 3. So 3 goes into 15 5 times, so 5 and 1. So you're just going to end up with a 5 on top, the one you don't need to put on the bottom. 4 minus 9 is -5, but negatives go on the bottom as positive. And you can kind of see there's more positives on the bottom. So when you subtract 4 and 9, you get 5. You're going to have e to the 5th on the bottom because there's more on the bottom. There's 9 e's on the bottom, and there's only 4 e's on top. So this on the bottom is where you're going to keep your e at because there's more on the bottom. There's 9 of them. So if you take 4 away from the top, you're going to have 5 left on the bottom. The next one, you can see as we zoom in a little bit on it, you've got an exponent to an exponent. Let me zoom in here for a second for you, and then I'll zoom back out. Whenever you see an exponent to an exponent, just put a times sign right next to them. And the 2 actually goes to both. So you're going to have 3 to the 2 power, and then you're going to have e to the 3x to the 2 power. So you're going to multiply that. And so you're going to end up with a 9 and an e and a 6x. 3 times 2 is 6. So 9e 6x. Now if you look at number 6 here, let's see what we got here. We've got a perfect square. I know it doesn't look like it, but you've actually got 4e to the 5x times 4e to the 5x. Because the 4 times the 4 is the 16. And then when you have the same base, you're going to end up adding those exponents, which is going to give you that 10x. So your answer is just 4e to the 5x. That is what you would have to multiply by itself to get that square root. So there's 1 through 6. Number 7, they're just asking you to describe the error. So let's zoom in a little bit more on that one. Describe the error, and let's see what they did. Okay, so the 2 to the 2, they did that, and 2 to the 3x right there. And then they got the 4, which is good, but then they got 3 times 2, and they put 9. They thought they were doing 3 squared. They thought they were doing 3 times 3, but that's not the case. You're doing 3x times 2. So what you should do there is put a dot right in the middle there and change this to a 4e to the 6x. Now it would be correct. All right, numbers 8, 9, and 10. Just asking us to tell whether it's growth or decay. Now I want to graph these. I just want to put them on Desmos for you so you can see them. So we want to put y equals e to the 4x. E little up caret is above the 6, and then little 4x exponent. And you can see your graph here now. I know it's kind of skinny. It's going in this way and then shooting up really fast. But as you read a book, you go across from left to right. As you go across, this goes upward. So that is a growth function. So underneath number 8 there, we're going to put growth. That is getting bigger as you go from left to right. And it's because of that 4 right there, because it's bigger than 1. Now let's look at this next one. Number 9, let's go back to Desmos. Let's exit that out. And y equals e to the negative x. So up here it would be above the 6, and then negative x. Again, negative x. This is a negative 1, which is smaller than positive 1, which is going to make this, as you're going across, you are going downwards. That's going to be a decaying function. That means the value is getting less and less and less. So this is a decay. Number 10, let's go ahead and type that one in. Y equals, now if we guessed at it, it's a negative 2. So it's less than 1. So my guess would be decay, but let's check it out and make sure. 4e, and then hit the up arrow above the 6 and put negative and then 2x. This is just Desmos.com. You can see as you're going from left going towards the right, this is a going downward function. So yes, that is a decay. We were right there. It was decay. Okay, so that would be up to number 10. Okay, number 11. Let's go ahead and look at that one. It says that we need to use the properties of exponents to rewrite the function in the form of this or this, depending on if the number inside is more than 1 or if the number inside is less than 1. Okay, so let's go ahead and try that. Let's do number 11. We're going to need a little bit of room, so you're going to use your paper here. I'm actually going to use this side over here. Okay, I'll leave it like that. And I'll do number 11 right there. And it's going to be y equals. And what we have right now is, I'm going to put it in parentheses because that's what the format we're going to need. And I'm going to put e to the negative 0.5x. Okay, so we could also rewrite that as e to the negative 0.5 and then put x on the outside because that's what we need for our formula. We need the exponent to be outside of the parentheses. As you can see here, this t right here is outside. That's going to be representing our x. This I can put into Desmos because e is actually a natural number. So we could go into here. No, this one, the scientific Desmos scientific calculator, and e, and we can do an up caret, and then it's a negative 0.5, and you get your decimal right here. Okay, so your decimal is 0.6065. Okay, so I'm going to put y equals, we're going to put 0.6065, 0.6065 to the x. Now, how much below 0 is that? So we're actually going to be using this second function because we know it's below 0. This 0.6065 is less than 1. Or not below 0, less than 1, sorry. It's below 1. So how much below 1 is it? So we're going to take this answer and subtract 1. Oh, wait, no, we don't want that. Sorry. Let's clear all. Okay, so let's take 0.6065 and subtract 1 from it. It's going to leave us with 0.3935. So that means this 0.6065, you could actually rewrite that as 1 minus 0.3935 to the x power. Now we're in the right format. There's no number in front, there's no a, but we have the 1 minus because it's going downward. And so what we can tell about this is that it's definitely decaying. It's going downward. And it's going to decay at a certain percent. And if you move this over 2 places, it's going to decay at 39.35%. That's how fast it's going to decay. So what this is going to tell us is A, is it a decay or a growth function, and B, how fast is it decaying and how fast is it growing. So that was 11. If we go to 12, I'm going to put 12 right below it. I'll leave that here for now. Okay, so let me get 12 set up so you can finish 11 if you're still writing it. 12, we've got y equals, and it's 2, which I'm going to put on the outside. That's going to represent my a. And then e, and I'm going to put in negative 0.2, close it, and then I'm going to put my x, because that's the format that I need. So now first thing I need to do is go back to Decimos Scientific and put in e to the negative 0.2 power and see what decimal I get. So let's clear all, and let's put in e, hit the up caret above the 6, and negative 0.2 power, 0.8187. So we're going to get y equals, let's go back to here, y equals, zoom in here for you. We've got the 2, and we've got 0.8187 to the x. So how much below 0 or below 1 is that? So let's go back to the calculator. And we're going to take that answer and subtract 1. That's what I needed to do last time. So it's 0.1813 when you round it off. 0.1813. So y equals 2 times 1 minus 0.8 or 1813, sorry. 1813 to the x. So now we can see that is definitely a decaying function again. It's going downward because it's a minus. It's less than 1. And if you want to know what percentage it's going down, move it over twice. 18.13%. Or about an 18.1% decrease or decaying function. And let's do 13. Okay, so let's go down here now and just go right below it. I'll leave that right there for you. We'll do 13 down here. Let me write it first. Y equals 5 E 0.6x. Okay, so we're going to get 5. And then e to the 0.6 and then times x. So let's see what e to the 0.6 power is. Okay, let's clear all, and we get E up caret 0.6, 1.822. Let's just go 1.822. So you're going to get a 5, 1.822, and then to the x. Okay, so now this is more than 1. So if I wanted to write it in our formula, we're going to put a 1 and we're going to plus 0.822. Because it's those two together would give me the 1.822. So we now know that this is a growth function. It's going up, and it's going up 82.2%. 82.2% growth. Okay, so there's 13. We're not doing 17, but 14, you can look at a Desmos. So let's go ahead and look at Desmos. We're not doing 17. Let's look at 14. Okay, so let's go to Desmos and type that in. E minus 1. Y equals E x minus 1 power. Oops, I need that. It's not putting it up there, is it? I'm not sure if it's putting it up there on X. This one. Okay, now we've got it. All right, there it is right there. Okay, so that's our exponential growth. See how fast it goes up really fast. Once you pass 0 here, it starts flying up. And that's our function. So what it wants to know is identify the domain and range. Okay, the domain and the range. Domain is your x numbers. Okay, so let's. Okay, so your domain would be the x values. Okay, so over here I'm going to put domain and I'll put x next to it. And your x values, you probably could see here on this graph. Oh, wait a second, what happened? Okay, it's going up. So the x values, right or left, are all real numbers. They go anywhere to the right, they go anywhere to the left. So it's going to be just all real numbers for your domain. The range is your y values. And if you look at the graph, y is not under 0, so y cannot be less than 0. So y cannot be less than 0. So y has to be greater than 0 for your range. So we'll cross out 15 and 16 because those are just graphing calculator ones. That should be enough on 6.2a to help you with 6.2 puzzle. See the next video for 6.3.